of shagaol in ginger, from ginger.
Good afternoon, everyone. This is Murthy, Research Associate from DHM Naturals. And our project is optimization of shagaol extraction from ginger powder and modification of solvent pH and its effect on extraction efficiency. And I am telling little about our company DHM Naturals. It's a natural health product startup and founded in last year September and located in Research and Innovation, Lambton College here at Sarnia. And our team members, Hardik, analytical chemist, and Daniel, process chemist. Thank you.
Good afternoon, both ma'am and all of my friends. My name is Hardik, and I would like to share some basic thing about our project. So first of all, introduction and what we did in this last 3 months. Also, like what's our company's research goal, budget, timeline, and many more things about future. So the first question is what is natural health product? So it's a kind of substance such as vitamins, minerals. So you can see in figure like it can be in many form. It can be tablet, it can be pill and capsule. And there are two main benefits of natural health product is first of all there are no more side effects as compared to allopathic medicine. And also it's obtainable without prescription, so yeah, you can go and buy natural health product. But some people got the side effect because of like without prescription, so if you take medicine, so it's always better to take medicine with prescription. The second question is why we choose only ginger. There are lots of natural health products like aloe vera, turmeric, and in ginger, why we choose, because there are more than 400 ingredients, and like some of our gingerol and shagaol. So if you know like the spiciness taste in ginger, so it's because of gingerol. And yeah, you can see the shagaol is one of the most active ingredients in ginger. So when we applied heat in ginger, so it gingerol converts into shagaol because of dehydration reaction. So you can see there is only one hydroxyl group here. It's a shagaol structure. And yeah, if I talk about the difference between gingerol and shagaol, so in quantity in ginger there are more gingerol as compared to shagaol. But if I talk about the quality, so shagaol has more health benefit. As you can see. For shagaol, it's anti-cancer activity and anti-inflation and many more. If I talk about our company's research goals, so we did isolation, purification, and optimize the extraction yield. And what we were expected is the peak of shagaol, like how much we got, what changes we did. And as fortunately we got what we expected, we got peak of shagaol in HPLC analysis. And this is the most important things, budget. That's because of this we all got different project. So as you know, the ginger powder is like $20, ethanol is $90, and it's all 20 sodium hydroxide and HCl. The most expensive thing is HPLC analysis. Ma'am spent $500 on HPLC. So the total budget is $650. and this was our initial proposed timeline. Like it's very straightforward. Like on first couple of week, we will do data material collection and extraction. On the week 7 to 9, we will do HPLC analysis and then report writing. But if I talk about the updated timeline, so on the first couple of weeks we did the same thing what we expected, like data and material collection and extraction. But after second week we had to change pH because of changing the extraction quality. But unfortunately we faced some pH issue on third week, and we changed two different pH meter, and then we got one pH meter which was suitable for us. So we completed our extraction and evaporation, rotary evaporator till week 6, and then we also faced some issue with HPLC because there was some error in HPLC column. But finally we completed HPLC analysis, and one we did FTIR. So lastly on the week 13 we did data collection, like data analysis and report writing. Thank you. Daniel will continue from here.
Good afternoon, everyone. Now I will take you further in our experiment. So first I would like to tell you about this basic thing. What is extraction? Extraction is a simple process in which we need to isolate any component from any material of our interest. So for example, making a tea. So here we are extracting caffeine or any flavors from that tea. It is widely used in oil and gas extraction, like oil and gas industries, in mining and in degrading and quarrying. Here are some types of extraction which are widely used in industries nowadays. First of all, distillation. It is very simple process, that's why it is widely used in industries. Solid phase extraction, supercritical fluid extraction, soap sludge extraction, ultrasound extraction, and acid base extraction. These are some of the extractions. So what is soap sludge extraction? The soap sludge extraction is a process which ensures intimate contact of a sample and a solvent. Here there is a contact between our sample and a solvent. It was invented in 1879 by Franz von Soxhlet and named after this inventor. Originally invented for extraction of lipids from the solid. There are three main sections of soap sludge extraction. First is percolator, in which boiler and reflux. Then there is a timble. It is a thick filter which is used to keep the sample. And one is the siphon mechanism. The reflux cycle when completes and beaker empty. When it empties, it calls periodically. It calls siphon mechanism. Why soap sludge extraction only? Like why we choose the soap sludge extraction? There were many methods as I have already told you. Why only the soap sludge extraction method? It is simple and clear. Here we can see a full process with our naked eyes. That how many cycles we have completed, how our extraction is going, and we can control the temperature and heat according to our needs. It is a continuous process. This is also a major factor. We chose this because we just need to start it once and it will be continuous. We don't have to interfere. If we want, then we can do. Otherwise, we don't have to interfere. It will be continuous. Ease of visual monitoring, as I have already told you, we can see it with the naked eyes and monitor what is going on. And have high extraction efficiency as compared to other methods. So working of soap sludge apparatus, it is really simple. I have already told you, so I I don't think so. I have to tell it again because it's just a time-consuming process. pH modification. Our main focus was on the pH modification. So we did pH modification with pH 4, like we made it acidic. Then we did we made it basic also with a pH 9. And in the first extraction, we didn't change any pH for our extraction. So these are the pH meters which we used, and this was a simple one. This was little complex, and this was the most important, or which we use for our extraction, in our extraction process, to know the pH, because this is the temperature control pH meter which we really required in our experiment. Evaporation and equipment used. So let me tell you, it's a simple process which changes liquid water to gaseous. It is the evaporation process, like drying of wet clothes outside. We use rotavapor for evaporation process. Here we remove the solvent from the sample by evaporation process. Why only rotavapor? We choose rotavapor because it is very fast and it is easy to use. Anyone can use just following the SOP. It avoids thermal decomposition. This is one of the most important factor. It avoids the thermal decomposition, so we can get our product as we want. And we need here less temperature than the boiling point of a solvent. For example, the boiling point of ethanol is around 78, and we can extract our solvent here at just around 45 or between 50, like we did. Process is done under control conditions, like here we can control the pressure and temperature as well. So this is the rotavapor, and this is the procedure of rotavapor. Storage of sample. This is also one of the important factor, because if we extract and if we done everything and we are not successful in storing of sample, then it's all waste. We used to do it like this. When we get extract from rotavapor, we used to add some DCM, and we used to keep it in a few mood for about a week, so we get a concentrated extract. And to avoid any further change in the sample, we use paraffin to cover it, or to avoid any contamination. So concentrated extracted yield. So when we haven't changed any pH, this is the concentrated extract we got. When we modified the pH to 9, this is the concentrated extract we got. And here, when we modified to acidic at pH 4, we got this concentrated extract. So there were no much change in the concentrated yields, as you can see here. Now Murthy will take you further. Thank you.
Till now, our group mates explained about our procedure like extraction and evaporation. After evaporating, we got the concentrated extract. From that, next step is analysis. We can see why we are performing analysis. Performing analysis in chemistry provides chemical or physical information about the sample or particular compounds. And then in analysis, it's basically two types. It's qualitative, to measure the quality of the compound, like how much purity or how much it's the quality. And then quantitative, we can measure the quantity, like how much amount is present. And for the analysis in the industries like pharmaceuticals or cannabis or petrochemical industries, these are the major instruments used for the analysis, like FTIR, UV visible spectrophotometer, HPLC, gas chromatography, and atomic absorption spectroscopy. We choose the HPLC because HPLC used to identify, separate, and quantify the compound in a mixture. So if you need to find out any particular compound like shagaol or any particular compound from the mixture of extract, we can use HPLC to identify and quantify the compound. And in HPLC, we can majorly identify, for the identification, we can use the retention time based on the peak, as well as for the quantification, we can measure the quantification based on the peak height or peak area. This information we can get it automatically from the software we used in the HPLC instrument. And this is our project HPLC method. For the instrument, we used Agilent 1260 Infinity 2. This one like a manual injector. Usually in the industry, companies use automatic injector samples. Here at the college, we used manual sample injection. And for column, we use C18. And the injection volume, 10 microliter, temperature 25 degrees Celsius. And major thing, we used DID detector, diode array detector. In the industry, different kinds of detector available for HPLC. For example, we can say UV visible detector and a PDA detector as well. For this analysis, we detected at 255 nanometer. For the HPLC software, we use control panel, and for the industry, some other popular software are Empower and Lab Solutions. For the HPLC sample preparation, after getting concentrated extract, we took 50 milligram from the concentrated extract and then we added 50 ml of methanol. After that, we filtered the sample using filter, because we need to filter is mandatory here, because you know in column it's like smaller diameter in size, so we need to filter our sample as well as for the standard solution, because it does not need to contain any solid particles inside the sample. And after that filtering, we collected the our sample in HPLC sample wire. This is the peak we got from our reference standard. This one for 410 ppm. These three are we got from our sample. This one like no pH modification, this one pH 9, and this one pH 4. And this is the result we got after HPLC analysis. For reference standard, we already know it's 410 ppm. So for this data, we automatically got from the software. We got the exact amount like a 410 microgram per ml. And then for the no pH modification, this is ethanol pH 7.30. In this condition, we got like around 180 microgram per ml of shagaol content. And we modified that one to pH 9. We got like 229 microgram. And then last one pH 4, we got like 268.552 microgram per ml. What are the amount I showed? These are shagaol content mentioned in that particular 50 milligram. After that, what are the struggles and strategies we did in this project? In that first week we faced extraction solvent volume, and then next week we faced with the issue with the pH meters. We used 3 different pH meters, and then end of like last 2 weeks we faced issue with the HPLC column, and maybe it's a sample degradation or standard degradation as well. And as per the conclusion, if we modify the pH to acidic level, we can improve the purity of the shagaol level up to 50%. And if we change to basic, we can see clearly it's 26.87% increase in shagaol content. So as per our experiment and the project for the last 4 months, we can conclude if you modify the extraction solvent of ethanol to acidic level, we can expect more purity of the shagaol. And for the future work, we need to do a lot of work as well, because it's like a short period of time, we are not able to complete whatever we expected. we need to do repeatability of experiment to confirm the data what we got in these experiments, as well as we need to check the sample degradation and standard degradation. And one more thing, we check the pH of extraction solvent before doing the extraction, but we don't do the sample pH after the extraction, but we need to check the pH of extraction solvent after the extraction as well, so we can confirm the pH is stable after the extraction as well. Thank you.